Welcome to Coding for Lawyers. My name is Matthew Stubenberg, and I am the Innovator in Residence here at William S. Richardson School of Law in Hawaii. I teach Coding for Lawyers and Cybersecurity Law, and today we are going to learn how to code and build legal tech applications. This video is essentially the first day of class in the semester-long Coding for Lawyers class that I teach. First, this video is made for anybody in the legal community who wants to know how software works. That may be judges, litigators, paralegals, law students, or people interested in going to law school. And second, this class is designed for people who have no prior coding experience. So if you don't have a lot of technology experience, don't be worried, we're going to go slow. Before we get started, one question I get asked a lot is, why do lawyers need to learn to code? I'll start by saying my goal is not to turn lawyers into full-time developers that leave the law behind. The goal is to have people who better understand what software can do effectively and what it struggles with. And the best way to do that is to get your hands dirty for a semester actually learning how to code. Throughout the semester-long class, we build applications to automate all aspects of a lawyer's job, from soliciting clients, generating documents, conducting research, and automating administrative tasks. Once you understand how software is written and what it can do, you can better identify tasks in your legal career that can be automated and those that might be difficult to automate. You want to make sure that you don't specialize in an area that can be automated and focus on areas that are difficult to automate. For the areas that can be automated, you will now have the language and technical understanding to work with full-time software developers to build tools that automate those particular legal tasks. Okay, let's go ahead and get started. Okay, so we have here a Green Acre traffic statute. It's a statute that will give points based on how fast you were speeding. It's very typical to the speeding statute that a lot of states have. And what we're going to try to do today is we're going to automate this statute. So using a computer program, someone who's been pulled over by the police and given a speeding ticket can determine how many points they are going to get on their license based on how fast they were going. So I'll let you pause it here if you want to read it. You can also find this PDF in the link in our description. So let's get coding here. So we're going to use a website called trinket.io. It's a free website that lets you enter code and it'll run it for you. They have a freemium model, although it's free to use for the purposes that we're going to use it for, and you can find a link in the description. I highly encourage everyone to code along. I think one of the best ways to really understand software and coding is to get your hands dirty actually writing code. There's something about actually writing it than just watching someone write it. So I encourage you, if you have two monitors, have the video up in one, have Trinket up in the other, or to be able to pause the video, type in what I'm suggesting, what I'm writing, hit run, see if it works for you, and then come back to the video. Okay, so we're going to write our program. And the first thing we need to ask is, if this person was sitting in front of us who had just gotten pulled over for violating the Green Acre traffic statute, and they wanted to know how many points on their license they were going to get, what questions would we have to ask them? So don't worry about tech or anything, just what general questions are there sitting in front of you. So if we take a look at the statute, 15102, which is where we're going to focus, says if they're speeding in excess of the posted speed limit by 10 miles an hour or more, you get 1 point on your license, and then 2 points, and then 3 points depending on how fast over the speed limit you were going. So what we're going to do is we're going to ask our person, how fast were you going and what was the speed limit? Those are the two key pieces of information we need in determining 15-102. So that's where we're going to start when we're writing our program. So we'll get to the point where we actually ask the user this, but for right now, we want to just do something called hard code these numbers in. We would just want to have some sample numbers to work with. Now, when coding, when you're storing or using information in your program, you're going to use something called a variable. And a variable, a metaphor for a variable that I've heard often, is a variable can be treated like a Tupperware container. And so you have this variable, a container, and then you can put information inside it and then use that container elsewhere throughout your program. So we're going to be writing Python today, which is a coding language. So we are going to create a variable to hold the information that we need. So in this case, we're going to create a variable called speed. And Python makes it very easy to create variables. All you have to do is assign it a word or create a word, and then we will make it equal to, and we're just going to put in a random number for now, just so we have something to test, 50. So this person was speeding 50 miles an hour. That's how fast they were going, 50 miles an hour. Now, when creating a variable, Python gives you a lot of flexibility in what you can use to name your variable. It's good practice to name it something that's going to relate to the information that that variable is going to hold. Otherwise, as your programs get longer and longer, you'll be confused as to what this variable is actually doing. And so you want to name it something relating to the information. There are a couple of rules around what you can and can't do with variables. You can't have spaces. They can't start with numbers. There's a couple of reserved words that they can't be. But there's a lot of flexibility in what you can name variables. So we're going to call this speed. So we're going to go on to the next line, and we're going to create another variable called limit. And we're going to make the limit equal to 25. So in our program, this person was traveling 50 miles an hour in a 25 mile per hour zone. They're going 25 above the speed limit, and they're going to get a certain number of points based off of that. So what we want to do now is we want to actually calculate what that difference is, right? Because that's mostly what the statute deals with, is how the difference between the limit and the speed. So luckily, this is something that computers are very good at, doing math. And so we want to create yet a third variable called difference and make it equal to speed minus limit. Now again, there are a lot of different other ways that we could have named these variables. We could have called it speeding or limit or speed limits or DIFF for short or something like that. All of those would have been completely fine. So don't get caught up thinking that these are the only names for the variables that these could have been. So if we run our program now, and we'll hit this little play button right up here, this is where the results are going to be outputted. You'll notice there's no output. We get powered by Trinket, which is just automatic, but there's no output here for anything. And that's because we haven't told our program to output anything to the screen. So why don't we go ahead and do that? And we're going to use a function here called print. And we're just going to print difference. So print is a function. A function usually gives you a lot of extra capabilities without adding a whole bunch of extra code into your program. So the print function, the code for that already exists. It's built into Python. You don't have to worry about it. But what it allows you to do is to print something to the screen, not print it to a printer, but print it to the screen. And what we want to print to the screen is going to be whatever we put inside the parentheses. And so here we're passing in the variable difference. And so Python is going to say, okay, we have a print function. We know something needs to be printed to the screen. What do we need to print? We got to print difference. Now note, they're not going to say we need to print the word difference. Python is smart enough to say this is a variable. They obviously want us to print the value of the variable difference, the information inside the Tupperware container. And so let's go ahead and hit run here. And so now it's printed the number 25. So we know that our calculation is correct. So far our program is working pretty well. Now what we want to do is we want to start to build in some of the actual logic behind our code. We're going to use something called an if statement. So we have the word if, and then we want to give the if statement the condition that is we want Python to test. And so we want to see if the difference is less than 10. Now, 10 is where the first tier of points come into play. If you're traveling less than 10, you don't get points. And so the if statement is written by using the word if. If is one of those reserved words in Python. Then we pass in the condition, which is difference less than 10. And then we have a colon at the end. And if this evaluates to true, what we want Python to do is run the code that is indented underneath the if statement. So I'm actually going to move myself over here so I don't block as much of the code. And so what we could do is we could say print no points. So I'm using the print function again, but I'm doing something a little bit different. Instead of passing in a variable, I'm passing in some text with quotes around it. So I'm using double quotes and I'm passing in some text, no points. That tells Python to write the text that I'm giving it to the screen. Now the if statement here, let's go ahead and run it and see what happens. Okay, so we see that we have 25 again, right? That's coming from line 4 when it prints to the screen. But we don't see no points, right? Which makes sense because on line 6, Python will say, is the value of the variable difference, which is going to be 25, is 25 less than 10? 25 is not less than 10, right? So that evaluates to false. So Python only runs the code that's indented underneath the if statement if this evaluates to true. Because it evaluates to false, it skips over any code indented underneath the if statement. So what we can do is we want to be able to catch the other side of that if they're going to get any points at all, right? So Python has a very handy function that pairs with the if statement called the else statement. So we can write ELSE and a colon. There's no condition this time. Else statements are used as a catch-all. And so if nothing else in the if block, and we'll talk about what an if block is later, evaluates to true, the else statement is run. And so we can go under here, and again, it has to be indented underneath the else statement in order to run. We'll say print. Now all we know is you will get some points, right? We haven't added any more complex logic than that. So what we have here is an if-else block right here, where if the difference is less than 10, this code will run. Otherwise, this code will run. So let's go ahead and run it and see what happens. Okay, we got some text. You will get some points. So let's go ahead and test our model here so we can change our limit numbers. We'll change to 45. This way they were only going 5 over the speed limit. And now they get no points. So our algorithm is working fine. So we've created the kind of the most simple algorithm that we possibly could. So this is great, but we want to make it a little bit more complex, right? If we go back to the statute, we see that there are several conditions that we have here. And so we want to check each one of these because we want to know exactly how many points are going to be assigned. So the first break here is at 10 miles an hour. And the second break is at 20 and then 30. So we need to add that into our logic here. So we already have this piece built in. We want to get rid of this for right now. And we want to build in a little bit more logic here. And so we could do that with something called the else if statement. And in Python, that's shortened to ELIF. And else if always goes after an initial if statement. So you can't start an if-else block with an else if. But we can add another condition. So now we want to check to see if the difference is less than 20. And if it is, we'll print you will get 1 point. And we can actually add as many else if statements as we want. Now make sure you're keeping track of the indentation. The indentation in Python is very important. So you'll notice that the if, else ifs are all on the same indentation. They're all the way to the left. All the code we want to be executed if that particular if or else if statement evaluates to true is indented, one indent underneath those statements. So in this case, it's looks like 2 spaces or 1 tab. So we'll print you will get 2 points. And what we can do now is we can use our else statement, and you will get 3 points. Okay, so let's run this here. We get no points. So far, so good, because the difference is only 5. So now let's change it to 25, and we hit run again. So you will get 2 points. So let's take a look at our statute and make sure that we're actually getting the right result here. So if we're speeding in excess of the posted speed limit by 20 miles an hour or more, you get 2 points. If it's 30 miles an hour or more, you get 3 points. So that's right. We should be getting 2 points on our license. So far, our algorithm is working pretty well. So I want to go over a little bit about what this if-else block is actually doing. So right now, our difference is going to be 25. The value of our variable difference is going to be 25. So on line 6, we're going to say if 25 is less than 10, then execute the code that's indented underneath that if statement. Obviously, 25 is not less than 10, and so this code is never run. What Python will then do is it will go down to the next else if or else statement, whatever's next. In this case, we have an else if statement, and it will check to see if that condition is true. So it'll say, is 25 less than 20? 25 is not less than 20. And so it will skip this indented code because it only runs that if the condition is true. And then finally, it'll go to line 10. It'll say, is 25 less than 30? Well, 25 is less than 30. And so what we can do is, what Python will then do is it will run this indented code. It will say, you get 2 points. And then it will skip this else statement because this else statement only runs if none of the other conditions above it evaluated to true. So let's do another example. Let's go back to our 45 example. So the limit's only going to be 5 miles an hour. And it says no points. So let's run through this again. So is 5 less than 10? 5 is less than 10, right? So it runs this code here. Let's say we go down to line 8. Is 5 less than 20? Well, wait a minute. 5 is less than 20. So how come this line here doesn't print? Well, what Python looks at is the entire if-else block as a whole, and it will run through conditions until it finds one that is true. As soon as it finds one that is true, it runs the code that's indented underneath it, and it skips all of the other else if or else statements in that if block and moves on to the next line of code. Our next line of code is line 14 here, where we don't have anything, and so the program just ends. So that's why you don't see all of these printing if the difference is less than 10. It's because only one of these will ever be evaluated to true in any particular run or instance of this program. Okay, so we actually have a pretty good working program right now. So now what we need to do is we want to look at the next part of our program. Actually, before I get there, one common thing I see a lot is this error. So if we hit run, we'll see this scary looking red box over here that says, we have if the difference is less than 10, we have syntax error expected : And so what this is trying to tell you is that you're not following the syntax that Python requires. There's something wrong with how you've written your if statement. Not from a conditional standpoint. There's a logic errors where maybe what you think is going to evaluate to true isn't actually evaluating to true. This is something called a syntax error, where you're not using the right language to tell Python what you want it to do. And so this is a very common one for new coders, is they forget to add the colon there. And so Python will give you some hint here. It says it's expecting a colon. So take a look at your code if you get this. It'll also tell you the line of the code where your error is arising. And so that's on line 6. And so if you just add that colon back in, your program will now run. Okay, let's take a look at 15-103, the MVA point accumulation penalty. So the MVA, the Motor Vehicle Administration, is going to do something in response to the number of points on your license. And we can see here, based on the number of points, they're either going to send you a warning letter, they will suspend your license for 12 months, or they will revoke your license. So let's build that into our program. Now, before we think tech, imagine this person is sitting in front of you. What information are you going to need to know in order to make this determination besides the speed and the limit that we captured before? So the answer is that we need to know how many points they currently have on their license, right? They may only be getting 1 point from their current infraction, but if they have 5 points currently, then that pushes them to 6, and then they get this suspended license. So we have to know how many points they have on their license. So what we can do is we can just add that in. We'll add a new variable to hold that new piece of information. And we will say, we'll call it points. And we're just going to hard code this in. We're going to say they have 4 points. Okay, so we have our points. Now what we need to do is we need to be able to add to our points variable depending on how many points they're going to get from their most current infraction, right? This is before we've done the analysis of their current speeding ticket. So luckily, we already have the logic built for this. What we can do is we don't need to worry about this because they're not going to get any points, so we don't have to add 0. So what we can do is we can say points equals points plus 1. So what we're doing here is we're saying take the variable points, take the value of the variable points, which is going to be 4 in our case, add 1 to it, which is going to be 5. So this highlighted section is going to evaluate to 5. And then overwrite or update the value in the variable points with that new value, which is 5. So points will now be worth 5 if this line of code is run. And we can do the same thing here. Okay, so now we have a variable that's going to capture the total number of points they have after their most current speeding ticket. So now we need to build some logic that's going to determine what the penalty from the MVA is going to be based off of how many points they have cumulatively. So what we can do is we can say, we'll go back to our statute here for a second. We'll say, okay, the first penalty takes place at 2 points. So if they have less than 2 points, nothing happens to them. And so we can say if points is less than 2, print no penalty. Now what we're doing here is we're building out a second if-else block. If the points is less than, I believe it's 6, let's take a look. Yep, and you get a warning letter if it's anywhere between 2 and 5. Then we have the next one here, which is, I believe it was 10. Let's double check that. It's 11. And that's the final one, so we can, after this, they revoke your license. So we have an if-else block here. This one determines the penalty based on the total number of points. And then we have this if-else block here that determines the how many points you're going to get from your current speeding infraction. So once Python finishes with this if-else block, it's going to treat this one as a brand new if-else block. Okay, so let's see how this is run. We'll go ahead and hit run here. Okay, you get a warning letter, right? And so we started with 4 points. If we go down here, if points is less than 6, you get a warning letter. And so that's what we're going to get. Now, in theory, they've already gotten this warning letter, but MVA might send another one because they've gotten a new traffic infraction. Okay, so let's change this up a little bit. Let's say they were speeding. Suspended license. Okay, so that right, you start at 4 points, you get 2 more, that brings you to 6. 6 is the cutoff here, right? Because 6 less than 6? The answer is no. 6 is equal to 6. And so it goes on to the next one here. Is 6 less than 12? The answer is yes. And so this is the code that gets executed. Now, in Python, you have a couple of these condition operators that you can use. So you can use less than, you can use greater than, you can use less than or equals, greater than or equals, and equal to equals. You can also use not equal to. So there's a couple of options you get to compare different conditions there. Okay, so we built a pretty good program here, but right now we're hard coding in these values. We want to actually ask the user for this information, actually make our program more interactive. So Python gives us this in a very basic way. In a real program, you might want to have a website, some kind of nice, pretty interface that people can use. But for right now, we're going to make this as basic as we can. So we're going to get rid of this 50, and we're going to write input, which is another Python function. And inside that, we're going to write the question that we're going to prompt the user so they know what information they're adding. And so we're going to say, how fast were you traveling? And I put it in quotes there. You'll see the quotes at the end there. I use double quotes. You can use double or single. You just have to use the same one on both sides. We're going to do the same thing here. Input, what was the speed limit? We'll change this to a question mark here. How many points do you currently have? So we see a little word wrap here. That's fine. You'll notice that trinket here isn't actually counting it as an additional line. Just line 3 is a little bit longer than normal. So that's completely fine. So let's go ahead and run this and see what happens. So we notice that nothing prints, and we get this, or none of the stuff that we normally see prints. And instead we see this blinking bar here, and we have this question, how fast were you traveling? So when Python gets to this input function on line 1, Python's going to say, okay, what they want us to do is they want us to stop running the program, pause right here, and get some information from the user. And so we're going to type in, we're going 50. What was the speed limit? The speed limit was 25. And how many points? I have 3 points. And if we hit run, we get the red box that indicates an error. And so if we read it here, we see difference equals speed minus limit, unsupported operand type for string or str and str. This can be a little confusing if you're new to coding. So before, we were using numbers, and in coding, they're referred to as integers. And that's what happened when we just had a variable here, something like, we'll call it temp right now, equals 50. We're assigning the number, or the integer 50, to the variable temp. And then we're doing the subtraction based off of that number, which is fine. Python is very good at subtracting and adding numbers together. So what's happening here? Well, the input function doesn't return a number. In theory, you could use the input function to ask the user anything. Enter your name, enter your age. So the input function returns whatever the user has given you, not as an integer, but as something called a string. And a string can be considered just text. It can be a single character. It can be a whole paragraph, a sentence, anywhere in between. So what we're actually getting, what the input function is returning to us after the user has typed in whatever they're going to type in, is something that looks closer to this. You'll see the quotes around it. And so we're getting something like the word 50, not really the number 50. And so then on line 4, what's happening is we're saying, okay, take the word 50, subtract it from the word 25, and that doesn't really make any sense, right? That sentence doesn't make any sense. And so Python says, we don't know what to do. These are words, not integers. We can only subtract numbers. And so it's throwing this error saying, we can't subtract a string from a string. Okay, so how do we solve this problem? Well, what we can do is we can use a function called the int function that basically tells Python that you can trust us. What we're giving you is going to be a number, so you can feel confident when you run math calculations on the variables that we give you. The way that we do this is we take speed and we make it equal to int speed. So what we're going to have is the int function, which converts the word 50 to the number 50, and we're going to pass into it our value. In this case, it's going to be the word 50. And we're saying take the new value, which is going to be, after the int function has converted it, is going to be the number 50, and replace the value in the variable speed with that new value, which is going to be the number 50. So we're swapping out the word 50 for the number 50. And we could do the same thing with limit. And we can do the same thing with points. So take a second here before I run it and see if you can see any errors that might pop up, right? So this will all successfully convert the values to the numbers so that we can run calculations on it. So take a second and think, is there any potential error that we might have when we run our program? We're going to hit play. 50, 25, and we have 4. And we still get this error. String and string, difference equals speed minus limit. Well, where is this happening? This is happening on line 4. Well, we haven't converted the words to numbers yet. So this is an easy thing to solve. We just need to do this above where we're actually doing the math calculation. And we're going to clean up our code a little bit here. And we'll hit run. We were going 50 and a 25 and 4 points. So now our program is back to working again, and it's actually interactive. Okay, so our program seems to be working pretty well here, but I want to propose a problem to you here. Is what if somebody runs it and they say they were going 50 and the speed limit was 65 and they currently have 5 points. Okay, well the difference is -15, no points, and you either already gotten a warning letter or MVA might send you another warning letter depending on how they do things. But wait a minute here. We have, this person wasn't in fact speeding. They were going 15 below the speed limit. So the question is, why are they using our program at all? And this is where you have to start to build in safeguards into your program, especially if it's a legal technology application. Because a lot of people are desperate for answers. Lawyers are very expensive, and so they may find your program, not realize that it only applies to speeding situations. And let's say this person was arrested for DUI. And so, they weren't speeding, but they got a DUI charge. Well, they're certainly not going to get this is clearly not the right legal advice, right? They almost certainly are going to get points if they're guilty of DUI. And so what we want to do is we want to try to build in some safeguards to catch people who might not fully understand what our program is doing. So how can we do that? Well, one way is we can clearly say at the top, this is only for speeding tickets. It's a good start. What we can also do is we can capture if the person is traveling less than 0 miles an hour, or if it's traveling over the speed limit by less than 0 miles an hour. So we could say if the difference is less than or equal to 0, print why are you using this app? And we can't have two if statements. They're going to treat it as two different else blocks. It's if-else blocks. And so we can do this, add it just as a secondary condition. And now if we run this, we're going 50 in a 45, and I have 2 points. Okay, so now we can run this again, and we could say, let's say they were going 50, and the speed limit was 65, and they have 4 points, minus 15. And now it says, why are you using this app? And with a little bit more coding, you could prevent it so that this warning letter doesn't apply either. And you can take into account for some of these things. But it's really important when building legal tech apps, especially for the public, that you try to account for other ways that users might use this and try to make sure that they don't get bad legal advice. And that's something that we try to work through all the possible ways to do that in the Coding for Lawyers semester-long class here at Richardson Law School. Okay, so let's talk about a few things here really fast. So think about where we got the information for how we made these calculations, right? In our app, we just ask the user. We say, how fast were you going? How many points do you normally have? How many points do you have on your license? What was the speed limit? This is sometimes a very good source of information, but it's not always the best source. A lot of times people won't remember how fast they were going, what the speed limit was, how many points they have on their license. So when you're building a legal tech app, you should always try to think of, are there other sources for this information? You can always get multiple sources and see if they conflict and then try to work through the conflict. Or you can get multiple sources. If they all say the same thing, you can feel more confident that you're getting accurate information. So one other source for this information would be the speeding ticket. You can imagine an application where you would take a picture of the speeding ticket and it could just take the information directly from the speeding ticket. The court case management system might have the ability to have your program interact with it behind the scenes and grab that person's information based off something like a name or a case number. Police records, right? Maybe the police system publishes all their arrests, and you might be able to find it that way. The car itself might actually know how fast it was going. Now, how you would access this maybe gets a little bit complicated. You might not actually be able to get to it, but that's not where we are right now. We just want to think of all the possible sources for this data and then maybe try to narrow it down to what's technically possible to get to. Google Maps has speed limits, and so if you simply ask the user where did you get pulled over, or if that's somewhere on the speeding ticket or in the case management system, you can then use Google to identify what the speed limit was for that road. So now I want to talk about objective versus subjective law. So right now, the statute that we coded, the part of the statute that we coded, was very objective. It was pretty much if you're traveling over X, you get X number of points. If you're traveling over Y, you get Y number of points. There wasn't a whole lot of subjective decisions that had to go into that. It's very black and white. But if we take a look at the rest of the Greenacre statute, there is a provision that's found in many state traffic statutes that says that a person may not drive faster than is reasonably safe for road conditions. And a person who violates this is guilty of a misdemeanor. Well, what is reasonably safe road conditions? And how would you get this information? So one option is to ask, were you driving faster than road conditions allowed? But that's not a great answer because the user might not know what that means. Reasonably safe is a bit of a legal term of art, and so the user, if it's a pro se user, might not know what that means. So you could ask all these questions and you could try to value it and say, okay, if it's dark outside and it was raining, that is not reasonably safe, but that could be a tricky thing to do. You could also use AI. So AI is getting better and better at determining some of these subjective areas of law. It's not perfect yet, so by all means, if you go this route, make sure you adequately have safeguards in place in case it gives you something wrong. But for the first time, we're actually able to use AI to feed in a bunch of facts, feed in past scenarios of convictions for traveling faster than what is reasonably safe on the road. And you could say, based off of these past convictions for this charge, are the current facts close enough to be considered driving faster than is reasonably safe? It's not perfect, but it is an interesting area that we now actually have access to that didn't exist just a couple of years ago. So now I want to talk about increased use versus increased accuracy. And this is the big issue with applications, especially those aimed at pro se users or non-lawyer users. And so the question is it better to help more people with less accuracy or less people with more accuracy? So we can always add lots of questions. And the more questions we ask, however, the less likely people are to complete the program. And so you then come to the problem of what is the acceptable error rate? So let's say that we could program our app to actually get the information, the speed and the limit from just taking a picture of the speeding ticket. But, however, we get a 2% error rate. For whatever reason, 2% of the time it gets the wrong numbers. When the user types in the information themselves, perhaps there's only a 1% error rate. However, the difference in usage is 10 times if you go with the automatic picture taking of the speeding ticket, because generally if you ask less questions, more people complete the program. And so now the question becomes, well, is it better to help 10 times as many people but have a 2% error rate, or help 10 times as less people but have a lower error rate? And this is a complicated question. I'm not saying I have the answer. And then let's say we add in the issue of what if an attorney's error rate was 3%? Does that complicate the decision? And so if there are people here who are perfectionists, they say that the smaller the error rate, the better, no matter what the consequences are. But keep in mind that 1 million people who went to LSC-funded legal aid groups, that's kind of like your local state legal aid, were provided with inadequate or no legal assistance. And this is because there just simply aren't enough legal aid attorneys to be able to handle the demand. And one way to try to bridge this gap is to use legal tech applications. But if you ask so many questions that the usage of it is minimal, then we haven't actually solved the problem. But you don't want to create an app that gives bad advice and makes situations worse for people. So this is a tough question to answer, and it's something that is continually debated in the legal tech community. So a few years ago, this is where the CLE would have ended. However, now with the advent of AI, I want to be able to show you how AI can actually help you in coding. So let's take a look here. So what we're going to do is we are going to ask ChatGPT here to see if they can write the code for us. Okay, so I have this prompt ready here that I've already pre-written. I'll give you a chance to pause that. I'll read it here in a second. And all I'm going to do is I'm going to drag and drop the Greenacre statute PDF that we just used. Now, keep in mind, this is not formatted in any way for AI or technology or robots. It's just a PDF statute that you would see in your own state. Based on the attached PDF, generate a program in Python that will ask the user what speed they were going, what the speed limit was, and what their current points are. Based on that information, determine if there will be any repercussions under the statute. Only use Python. A new coder would understand. Do not use functions. Those last pieces are just so that everyone will be able to understand the code that ChatGPT generates. And in a matter of seconds, it has coded something that looks very similar to what we coded that took us almost 20 minutes. And so what we can do is, just to make sure it works right, we ask the user here using the input function. We can see that they wrap it in an in function there, which is they just put it on the same line. We broke it out in 2 lines. They do the same calculation to determine what the difference is. They called their variable speed over limit. And they have a very similar looking algorithm. They went in reverse order. They went, is it greater than 30, greater than 20, or greater than 10? We did the opposite. From less than to greater than. But it's remarkably close to the code that we actually just coded here. Okay, so let's make sure that it actually runs. So I'm going to just replace the code that we wrote with the code that ChatGPT gave us. These little green lines are something called comments. They are notes that are added to code. They're not actually run by Python. They're designed to be seen by coders to help people understand what different lines of code are doing. So we'll go ahead and hit run and enter the speed you were traveling. We're going 55 and a 40, and I have 2 points. Okay, so it's able to calculate. We're going 15 miles over the speed limit. Points to be added, 1. That looks to be right. Our total points is 3. That's right, and you will receive a warning letter. So the advent of AI and ChatGPT to write really good code is going to change how all software is written, including legal tech. Before, one of the biggest barriers to entry was to find coders that could help you write the code that you wanted to. But now, coding is going to be so easy, especially going forward as code just gets easier and easier to write. We might see a proliferation of legal technology apps on the internet. And this brings up a whole new scenario and set of problems where people who might not be lawyers or legal experts can write their own legal tech apps and put them on the internet, where people might not know that it wasn't vetted by an attorney and that the law could be incorrect. And so it's a very interesting area to be in right now. And so we'll have to wait and see how ChatGPT and the ability to write really good code really quickly is going to change the game in the legal tech space. Okay, thank you so much for making it to the end of the video. If you want to follow me, here's my Twitter handle. And if you have any questions about legal tech, feel free to put them in the comments of this video. And I think we're going to be adding more and more legal technology videos to our YouTube channel, so make sure to like and subscribe. Thank you so much.